Alright, here's a demonstration and explanation regarding all of the numbers and stuff behind all this pH, or what I might call what's up with all this log and negative log stuff anyway. I'll use a spreadsheet to show you some of these intricacies, or kind of peek behind the curtain. So the first thing I'm looking at here is I've written a whole bunch of numbers typically or commonly associated with concentrations that we experience in a chemistry classroom. So we might have a concentration of 0.1 or 0.01, or even sometimes we end up with numbers like 0.0001. So if we look over here, we can see that there's a number of different ways of writing these numbers, and you need to be able to write these numbers. So let's just see if we can see a pattern here. And it's not enough just for you to see the pattern, you need to know, memorize, and be able to reproduce the pattern yourself. So this is the decimal way, or what they call the decimal equivalent. And so now let's take a look at the scientific notation way, and that's the one where you're doing something times 10 to the something or other. So let's just start right in here, and I'm just going to change this. This is my little shortcut I did here. So notice the pattern here. There's a 1 there, and the -1 says there's a decimal point, and the decimal point moved in the negative direction one place. So over here, exactly the same thing. There's a decimal point move, 2 decimal point moves. So if we click here, we can see that. If we click here, we can see this, and you should see the pattern pretty quickly. So in every single case, these little wee numbers, these little exponents, are saying how far the decimal point has been shifted. Now I'll mention that I've always picked really nice numbers here. The number always ends in 1, and because it always ends in 1, this first value right in here is always 1. Now before I go to the log way and the negative log way, I'd like to peek in here, and this is what I call the nths way of talking about it. So in other words, 0.01, normally what we would say with that is we would say that's 1/10. And for 4.01, we would normally say that's 1/100th. And of course this 10 to the 3 is 1,000, so 10 to the -3 is 1,000ths with the th there. So 1/1000ths, and that would be 10,000ths, and that would be a millionths. And let's just peek in here. And remember, you can always hit pause if you need to write, if it would help you memorize this stuff, to write it down. Sometimes instead of saying 1/100th, we sometimes just do a little shortcut, and here are the little shortcuts. So in other words, sometimes we don't say 1/10th, we just say a tenth. We don't necessarily say 1/100th, we just say 100th. Okay, so it's important for you to be able to get the th names for these different values or quantities as well. Okay, so back to here. These are relatively clunky numbers, and sometimes you get sick of writing all the decimal points right in here. So if we just focus on the log value, which is to say just this little exponent thing in here, you need to be able to do see the log value way of expressing these numbers. So in here, the log value would be just that single 1. The log value would be just that 2, would be just that 3, would be just that 4, etc. And I think I've already done that here. And you can see that. Oh, actually it's not 7, it's -7, because the log is basically saying what is the 10 raised to the power of. Now, here's the thing about pH and the idea of negative log. So, a lot of the quantities that we deal with in the case of pH and concentration, they have these weird numbers. They've got a lot of decimal points before the 1. So in other words, there's a lot of negative values, or there's a negative value in front of the exponent. So a shortcut is when I like to think of it as we p on it. So what we do is we just say, okay, well, I'll tell you what, instead of calling this value right in here 10 to the -6, we know we're dealing with small numbers, see 1 millionth or 1/10 millionth. So let's forget let's not waste our time writing the negative, even though we know it's there. So we'll stamped it no rubs out declare logs as being, or sorry, p's as being the negative of the log. So we'll take all of those negative values and we end up with this. So what you need to be able to go through is you need to be able to see and remember the patterns as we drop down in here. So you should be able to take anything out here. I should be able to hide that. You should be able to fill in each of these little wee spots. So in other words, if I were to go click, 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 and if I were to hide these things here, then you should be able to fill in all of these different values. And the way you would do that is you would copy that table out, and then you would practice covering them up, and you would rehearse filling those in. So let's go back to this right in here. Great. Okay, so these are the p-values. So remember, p is the negative log, and the negative log is, or the log value is this thing up in here. So what's going on with pH? Well, if we're talking about the H concentration, if we p'd on that value, then we would have something called a pH. It's the p value of the H concentration. What about if this number right in here was talking about the chloride concentration? Well, then that number right there would be the PCl value. What if this number were talking about the hydroxide concentration or the OH concentration? Well, then that would be the P value for the OH, also known as POH. Repetitively, what if this were the H plus concentration? Then that would be the P of the H value, also known as the pH value. What if this value were the K value for an equilibrium constant? Well, then this would be the pK value. What if this were the equilibrium constant for an acid-base equilibrium? Then that would be the pKa value. Alright, the next video I'll do will be, what about if the number isn't a nice number like 0.00001? What do we do with numbers like 0.000063 or something like that? How do we p on those particular values?